This video will be over dividing rational expressions. The rational numbers or expressions can be divided according to this rule. When you have two fractions that are being divided, so AB divided by CD, we can keep the first fraction, flip the second fraction, and change the sign. And then multiply across, or use your multiplication rules. So anytime you have a division, you're going to KFC, keep, flip, change, and then work your multiplication rules. So to begin, let's look at regular fractions or rational numbers. So 3/10 divided by 4/15. What we're going to do is keep, flip, and change. And then we're going to reduce. So 10/15, that's the same as 2/3. Multiply across, we'll have 9/8. So same with our rational expressions. You have the following problem. You will keep, flip, change. Now while I keep, flip, change, I'm going to factor as I work these instead of rewriting this as, this fraction, flipping that fraction, and then multiplying, and then factoring. I'm going to go ahead and factor as I write. So the first fraction we're going to keep. So I'm going to factor the x squared minus 16. And on these, the tedious thing that you're going to be working with, or the thing that will take you the most time, is the factoring. And then we're going to flip the fraction, change the sign. So as I flip it, and if you want to, you can flip it and then factor it, so you're not placing your factors on the wrong side or the wrong level. So the numerator, the factors will go into the denominator. So this will be x plus 7, x minus 7. This denominator will now be our numerator. And let's go ahead and factor it. So that would be positive 4 and negative 3. Now the fun part, we get to cancel. So x plus 4 cancels out, and the x plus 7 cancels out. When we multiply across, we will get x minus 3 in the numerator and x minus 4 times x minus 7. Do not multiply these out. Do not use the FOIL method. Leave them as factors. Otherwise, you're doing too much work and you are unsimplifying your answer. Okay, this one's our next example. Now these aren't necessarily in fraction form, but to put them in fraction form, we can place each of those over 1. So we will keep the first fraction, and I'm going to go ahead and factor. And if you want to keep, flip, change before you factor, go right ahead and do so. I like to be efficient and work the factoring as I go. Then we're going to flip the second fraction, so our denominator will be our numerator, so I'll place a 1, and then our numerator will become our denominator. So then we will factor. And then we have x plus 3 over x minus 5. do not cancel those x's because they are bound by addition or subtraction. A little side note here, if you did cancel those out, let's say you canceled them out and you got 3 over negative 5 as your answer. You're not always going to get 3 over negative 5 if you plug in a value for x. So let's say we pick a value of x. The only time it will be 3 over negative 5 is if you pick 0 as for x. Let's pick x equals 1. 1 plus 3 over 1 minus 5, you will get 4 over negative 4, which is negative 1. These two do not cancel. These two do not equal each other. So you cannot cancel those x's. Because no matter what number you put in for the x, you will get answers that are not equal to 3 over negative 5, unless of course you use 0. Okay, this next one involves a little bit more work, and again, like I said, the biggest part that will take you away from what you're doing is the factoring. The factoring may take the majority of your time, and it is tedious. It does get quite tedious. So let's look at this example, and we are in division, so we have to keep flip change. Well, before we go ahead and keep flip change all of it, let's work this one at a time. So for the first fraction, we are going to keep it as is, and I'm going to factor. So I'm going to start with the denominator because I see we can factor out a 9, and we're left with 3x plus 2. Then our numerator, instead of factoring it all through here and messing all this up, I'm going to do some side work to factor. So 3 times negative 18, that's 54, or what I do is just go 3 times 18, and then 18, I have 9 and 2, and I'm going to combine these in different ways. So 3 times 2 is 6, so we have 6 and 9. Well, that doesn't add to 25. I can't get a combination of 6 and 9 to equal 25. The next one I'm going to use is 2, and 9 times 3 is 27. There I can work 27 and 2 and get 25. If I make 27 negative and 2 positive, which is what we need, because negative 27 times 2 will give us that negative 54, that negative 18 times 3. Negative 54. So that is negative when you multiply it, and then if you add those together, we will get a negative value as well. So we are going to rewrite our trinomial using our factors we found. Factor by grouping. And then factor again, which I'm going to put the resulting factors over on my work. And then we kept the first fraction as is. We just paused and factored for a little bit. Now we're going to flip the second fraction and change the sign to multiplication. Well, our numerator does not need to be factored, so when we flip it, it will now become our denominator. Our denominator will become our numerator now, and again, I need to go off to the side and do some side work. So I have 5 times 18, which 18 is 6 and 3, or 9 and 2. It does not matter. Just get 2 factors, and then you're going to combine them. So like 15 and 6, that won't work. 5 times 3 is 15. You have the 6 left over. 30 and 3 will work to get negative 33, but they both have to be negative, because 2 negatives will give us this positive, well, positive 90 then, 5 times 18. So we will rewrite our trinomial so that we have 4 terms, and make sure our 2 middle terms add to the middle term. Factor by grouping. And then factor again, which I am going to put the result in where I am working our problem. So like I said, the biggest time consuming thing you're going to do with these is factoring. Once you factor, then it's pretty easy. You take away the 3x plus 2's because there's one in the numerator, one in the denominator. 5x minus 3 is also canceling out. And then we have left x minus 9 times x minus 6 all over 9. This concludes this video.